We've been asked to use the properties of circles and tangents to discover the length of this arc from A to B. Right here, I'll just highlight that in red. So we've got a circle, maybe it's a planet or a moon, and we're viewing that planet or moon from a distance. We're able to focus on the center of it, and we're able to see via these two tangents a point A and a point B, and we know that we're 5 kilometers away from point A. Because we know that we're 5 kilometers away from point A, that means that we're also 5 kilometers away from point B. Want to highlight this other side, we would say that this line is equidistant to this line, so this is also 5 kilometers. But we weren't asked about that line. We were asked about the red line here, this arc. What is the distance on the surface of this circle from A to B? Let's talk about the surface of a circle first. The surface of a circle, we would know that more as the circumference of a circle, also known as the perimeter. And the circumference of a circle is pi times the diameter, or 2 pi r. Our radius is 2, so our diameter is 4, and so we can say that our circumference is 4 pi. 4 pi is approximately 12.57. All right, so this particular planet or moon or small rock or whatever is 12.57 kilometers in circumference or perimeter. Perfect. That's the entire distance around the whole circle. We need to know this portion right here. If we're able to figure out a angle that works for us, or a portion of the circle, we'd be able to get that distance, right? Like if we said we were 50%. If we said that the red line here was 50% of the circumference, we would know that that was half of 12.57. Now, I don't know that it's 50%, but I might be able to get the percent. Take a look at this angle inside here. I'll call this theta, and that means that this angle right here is also theta. Those are two of the exact same angle, and that's due to the property of these two tangents hitting this circle from the same point. If I'm able to discover what theta is, then I would know the certain number of degrees or radians around this center of this point, which would mean I would know how many radians or degrees this section of the arc is on the right, which is equal to that section of the arc on the left. How do we discover that angle? Well, let's take a look at the fact that we've got two right angle triangles, and we're really only going to focus on one of them at a time here. So I've got a right angle in here where A might not be fully visible anymore, so there it is. So I've got a right angle triangle on the right-hand side here, and two of the legs are 5 and 2. If we were to draw this triangle over on the side here somewhere like this, we don't know the hypotenuse, but we do know that the legs are, 2 and 5. The angle in question would be this one right here, and we'd go to our trig in order to figure this out. So from SOHCAHTOA, and the reason why we're using SOHCAHTOA is because it's a right angle triangle. I know that I need the opposite side and the adjacent side. So this is going to be a tan question. So the inverse tan of 5 over 2 gives me my angle, which I called theta. So if we go ahead and we do that, we get approximately 68.2 degrees. And so we'll say theta is, approximately 68.2 degrees. Okay, so that's this inside angle right here is 68.2 degrees. And that means that the entire slice is 136.4. So if I say 2 theta would be 136.4 degrees. You could do this in radians as well, 100%. I chose to do it in degrees. Well, we know that a full circle is 360 degrees. So if we were to get this as a percent, we would say 136.4 degrees is to 360 degrees, and that gives us a certain percentage. That comes up to 0.378 repeated, blah, blah, blah. So we're going to say that that's approximately 38%. So this little area right here that I'll just finish with the red arc, that is 38% of the circle. You can kind of look at it visually too and say, is that a number that makes sense? If we were to go the full halfway, which would be 50%, then we'd be dealing with a diameter, something like this. But in fact, we didn't go a full 50%. So yeah, 38% in terms of the drawing here makes sense to me. So let's go back to the original part where we discovered the circumference of the circle. if I know that the entire circumference of the circle, all the way around, is 12.57 kilometers, then I can easily say that what I have here is 38%. Just noticed now I had that as a degree symbol, 38% of that 12.57 kilometers. So we're going to take 38% or 0.38 of 12.57 kilometers, which is the entire distance around that circle, but we're only going a portion. That comes out to 4.0775. I'll go a few more decimals than what I've been doing. So 4.775 kilometers. So the red arc from A to B, so therefore the distance from A to B, or the length of the arc, if you will, from A to B, is 4.775 kilometers. And that's why these properties of the circles that we've been taking a look at is really important. We're able to use them in a combination with our previous knowledge of trig and circles and just basic geometry to discover things and to mathematically calculate distances, lengths, areas, volumes, all these things that normally we wouldn't be able to, because you're not going to get out there with a ruler and measure the edge of a 4.5 kilometer circle. Now, there's going to be other reasons why you might use some of these tools, and always need to, ask yourself, what do I know? What don't I know? And this all started with me understanding that the full distance around the circle would have been the circumference. So I discovered that, and I only have a portion of the circumference. Then I saw I had a right angle triangle. I can get the angle of a right angle triangle because I know SOHCAHTOA and the basic trig ratios. And I went from there. So I hope that was helpful, and keep working on your math.